Yes, initially, if you start with the integration, that is x to the power n integration is this. So therefore, there's a one restriction over here today. N is not equal to minus 1. Right. What do you mean by this? N is not equal to minus 1. This is a situation, for example, if you integrate x to the power 6, what is that answer? X to the power 6 plus 1, 7 over 7 plus 6. It's not a problem. But if you want to integrate 1 over x, what is that answer? That is turned up to integration of x to the power minus 1. X to the power minus 1. Right. Then if you integrate x to the power 1 and if you use this formula, answer is x to the power minus 1 plus 1 divided by minus 1 plus 1. That is x to the power 0 over 0. That is 1 over 0. So you can say this does not exist. Not exist. Does not exist. So that is the fact where we have to understand. Therefore, this formula is not valid for 1 over x or integration of x to the power minus 1. Apart from that, any other powers, it's not a problem. Like if it is x to the power minus 2 or half, whatever, it comes. X to the power 2, no, this is x to the power minus 2. With that, you can say x to the power minus 2 plus 1 over minus 2 plus 1. That is x to the power minus 1 over minus 1. That is minus 1 over x. So this is not a problem. For a fractional powers even, the same things does not make any impact to them. X to the power half, that is x to the power half plus 1 over half plus 1, that is x to the power 3 over 2 over 3 over 2. Yeah, like that. So with any other fractions, any other values except minus 1, this integration is valid. That is the part where we have to understand. Right, okay. Then, yeah, so therefore, what would be the answer for this x to the power 1 over x to the power integration? That is a fact where we have to understand, right? The integration of 1 over x. We know that if you differentiate ln x, what is the answer to that? If you integrate ln x, answer is simply 1 over x. Therefore, if you integrate the both sides, what do you get? The whole differentiation integration it cancels, turn up to integration of 1 over x into ln x. So we can say this answer is today. This is the case where n equals to minus 1 prime. So you can say this answer becomes ln x. That's the next example where we have to understand. Right. Similarly, these are the basic facts, basic two integrations of e to the power x where we supposed to learn from it, right? Okay. Then today, yes. Then this is a theory, so you can, when you're writing, you can write down this note. Then the next fact is today, if you want to integrate ax plus b to the power n, the answer is this. Answer is ax to the power. So here there's another part will come. Ax plus b to the power n plus 1 over n plus 1 is there. Apart from that today, there is another term x into 1 over a. This has to be multiplied with 1 over a, the constant over here. That is the fact where we have to understand. Here also the same condition comes. N is not equal to minus 1. For example, if you work out with this example, integration of 2x plus 3 to the power 5. Answer is 2x plus 3 to the power 5 plus 1 is 6 over 6 into 1 over a is 2. The number in front of x, that is 2. So final answer becomes 2x plus 3 to the power 6 over 12. Plus 3 is the final answer for this. Right. Let's go ahead with another example. If it is integration of square root of 4x plus 3. So this is the integration of 4x plus 3 to the power half. Square root is power half. Yes. Then, yes, I write it a bit of larger than that, you may not see this. Integration of 4x plus 3 to the power, sorry, the square root of it. That is integration of 4x plus 3 to the power half. If you do this integration, the answer is 4x plus 3 to the power half plus 1 is 3 over 2. Over 3 over 2 into 1 over 4. Then this 2 goes up. So finally turn up into 2 over 4 into 3 is 12. 4x plus 3 to the power 3 over 2. So you can write 1 over 6. And you can say 4x plus 3 to the power 3 over 2 over 6 plus is the final answer for this. Right. Then we know what is the integration of that one as well. Right. Yeah. Then the case n equals to minus 1. That is the integration of 1 over ax plus b. No other powers are there, dx. In this case, same way, you cannot apply for it. The answer is 1 over a ln ax plus b. Those are the situations where we have to understand. Right. Right. That means if you integrate 1 over 2x plus 3. For any other powers, you can use that formula. The answer is 1 over 2 ln 2x plus 3 plus c is the final answer. It is only relevant if the power is minus 1 only. Right. If you go ahead with another part of it, just like the same function, if it is 2x plus 3 to the power 2, if it is so, therefore no need of using this ln, because we know that it's coming up like this. 2x plus 3 to the power minus 2. So final answer is 1 over 2, 2x plus 3 to the power minus 2 plus 1 is minus 1 over minus 1. Answer is minus 1 over 2 times of, minus 1 over 2 times of 2x plus 3. That's the final answer for this question. If it work like this. So these are the first extent formulas where we supposed to know. But initially, we should know these formulas. Right.
Sir?
Yes, Sudhiri? Yeah, can. I'm listening to you. Umar is there, no?
Danvika.
Others were there. How many of them there? It's all the time. Yeah, right. Now let's start. Then that is the integration of 1 over x. So x function, x to the power n function with 1 over x. Ax plus b to the power n function with 1 over ax plus b. Right. The next part of it. Next part is the integration of exponentials. If you want to integrate e to the power x, e to the power x, answer is e to the power x itself. It doesn't make a difference because we know that if you differentiate e to the power x, answer is e to the power x. If you integrate e to the power x even, you get the same answer. So those are the first set of formula in exponential we need to know. The next extension here is if you
So is it a plus b?
Yeah, plus e should be there. I am not writing plus e because it's the excess amount of it. If it is ax plus b, e to the power ax plus b. If you need to integrate e to the power ax plus b, answer is 1 over a e to the power ax plus b plus c. Plus c I am not adding to this one because like it's the excess amount later on it comes to the So this is the final answer for that. If it is ax to the power, for example, if you integrate e to the power 2x plus 3, answer is 1 over 2 e to the power 2x plus 3 plus is the final answer for that. That is the example for that. Right. Then the next part is, this is the important point for this. The next part is little bit important. Just if it is just only ax plus b, not any other function, right? That means if it comes with any function like this today, the next extension of e is e to the power any function over here. For example, e to the power x squared plus 3x plus 1. This is not ax plus b format today. And if the differentiation of this power is available as a multiplication, e to the power any function, and its differentiation is available as an excessive to this function as a multiplication, then you can write, ignoring this bit straightforward, I can write this answer. That is the rule for that. For example, into e to the power this e to 2x plus 3. Then what you can see? You can see the differentiation of this bit. X squared plus 3x plus 1 is how much today? 2x plus 3. So, in that case, you can straightforward write, this is e to the power x squared plus 3x plus 1 plus c is the final answer. Let's go into another example. If you want to get e to the power 6x squared, this is 12x here. Then what you can see? The differentiation of this is available here. So straightforward, I can write the final answer, e to the power 6x squared plus c is the answer for that. That is how it comes for it. Right.
So I don't understand.
Sorry, Pate?
So can you explain that differentiation part? I don't get it.
Here, look at this, Pate. E to the power some function over here. What is the differentiation of 6x squared, Pate? If you differentiate 6x squared, is how much, Pate?
12x.
12x, right? So this differentiation is available here. If it's so, straightforward, ignoring this part, you can write this one as final answer. Right. If you go to another example, then we are going to e to the power 5x cubed plus 6x squared. And here outside 15x squared plus 12x is there. Then what can you say? The differentiation of this bit, it's available here. Isn't it? See whether what is the 5x squared differentiation is? 5x cubed differentiation is 15x squared plus 6x squared differentiation is how much today? That is 12x. So here the differentiation is available here. Therefore, you can write the answer. This is e to the power 5x cubed plus 6x squared plus is the final answer for this. That is the way of getting this answer. Right. Let's go into the another part of it. If that is not there, how to do that question? That is another point where you have to understand. You can hear it. Just wait for another example. Then we have to get e to the power 6x squared times of we have 3x dx. What is the differentiation of 6x squared? Differentiation of 6x squared is 12x. But here we have 3x. Here we have 3x. In such situation today, but we know that if you multiply this 3x by 4, what happens? You can make them into 12x. So any integration you can multiply by a constant, not a problem, but you cannot multiply by a variable. You can multiply by a variable, but by a constant. Therefore, I just do like this. 6x squared, this 3x I will multiply by 4. But this is some kind of an excessive fact to this question. To correct it today, I will put 1 over 4 outside from this integration. That means the purpose is this 4 should be balanced with this. 4 into 1 over 4 is how much today? We get cancels out of it. And you just forget about this part of it. To correct it, I am putting 1 over 4 over here. It's not a problem because if you multiply by 4 and if you multiply by 1 over 4, again it cancels. Then take this part outside. And you can write e to the power 6x squared into 12x. Now see whether the differentiation is available here. Yes, it's available there. Then you can write your final answer is 1 over 4 e to the power 6x squared plus is the final answer for that. You can multiply any integration by a constant but not with the variable. That is the fact where we need to understand. Right. Let's go ahead with another example. Right. E to the power 5x squared plus 4x 5x squared 5x plus 2. Now see what is the differentiation of 5x squared plus 4x to that. That is 10x plus 4. 10x plus 4. But here the value is how much? It's 5x plus 2. Can we multiply this 5x plus 2 by a one constant figure and can you make them into 10x plus 4? Is there any way where we can do it? Yes. If you multiply this 5x plus 2, this 5x plus 2 by 2, you can make them into 10x plus 4. But you have to correct it, you can put 1 over 2 outside. This excess fact, I will take it as outside. Then you can write e to the power 5x squared plus 4x times of 10x plus 4. Now you can see the differentiation, this is available here. Okay, then what you can see? Then you can write the final answer 1 over 2 e to the power 5x squared plus 4x plus c is the final answer for this. That is a way of getting this integration. Right. Then the next part is that. The next part is this theory to it. E to the power fx into gx, where gx is not similar to f dash x. What is the theory? Here the differentiation of this is not over here. For example, a situation like this. E to the power x squared plus 4x plus 1 is x cubed plus 2x. This kind of situation. Here, the differentiation of x squared plus 4x plus 1 is 2x plus 4. But here it's not that. So you cannot find the differentiation of the power of exponential as an excessive function. So in that situation, what we need to do? That is the problem where we come across. So this theory we will be learning in our future. This is called, later on we learn, this is coming under integration by substitution or by parts. We will learn this one in our future sessions. For the moment, remember that there is a way of doing it without learning more into facts. You cannot do this integration. Therefore, we will pause for a while. Right. Okay. Now let's go to the next part of the theory. Okay. So now you know how to do this kind of integration of exponential functions. Right. To make them into adjusted, what you need to do, you can multiply by a constant and you can adjust it, but you can multiply with a variable and you cannot multiply with that. That is the fact where we need to understand. Right. Then for the integration of trigonometric functions. Integration of trigonometric functions. Right. Integration of trigonometric functions. Okay, we'll start with the integration of cos x. we know that if you differentiate sine x, what is that answer? What is the differentiation of sine x? We already learned this back.
Cos x.
It's cos x. Then if you integrate the both sides, what happens? This differentiation and integration get cancelled, turn up into integration of cos x become sine x. So the answer is this, sine x. That's the first trigonometric integration formula we are supposed to learn. Right. Then the next extension is if it is a function like this today, cos ax plus b. Answer is today 1 over a sine ax plus b plus c. Plus c should come to the end. For example, just like this. If you want to integrate cos 5x plus 2, not x squared and x cubed terms is not applicable, only for x. So answer is 1 over 5 sine 5x plus 2 plus c. If you go ahead with another example, integration of cos 4 minus 3x. So answer is minus 1 over minus 3 sine 4 minus 3x plus c is the final answer. 1 over minus 3 is minus 1 over 3. If you want, you can write it that way, but that is does not make any impact to the final answer. Right. Then we should know integration of sine x. We know that if you if you differentiate cos x, what that answer to be? If you differentiate cos x, answer is minus sine. Then I'll integrate the both sides again. Then dx get cancels cos x, and you can take this minus 1 out. Sine x. Then you can write integration of sine x. If you brought this minus 1 to other side is cos x divided by minus 1, that is minus cos x. Therefore, integration of sine x will become minus cos x plus c. Plus c should be here. That's the answer for integration of sine x. Integration of cos x is sine x, but integration of sine x is today minus cos x. Right. Then the next part of it is if you want to integrate sine ax plus b. Answer is minus, that comes to the same way, 1 over a cos ax plus b plus c comes to the end. So that is the answer for that. For example, if you integrate sine 6x plus 2, answer is minus 1 over 6 cos 6x plus 2. Like that, you can get the answer. Okay. For example, another one, if it is sine 2 minus 6x, answer is minus 1 over minus 6 cos 2 minus 6x plus c. So that is 1 over 6 cos 2 minus 6x plus is the final answer for that. So difference integration of cos x is sine x, integration of sine x is minus cos x. That is a fact where we need to understand today. Right.
Sir?
Yes. Yeah.
Plus 1 over
Shouldn't
6.
it be plus? Yeah.
Sorry, it's plus. Sorry. I made a mistake. It's plus. Sorry, I made a mistake here. That's correct. Thank you. Yeah, let's come to the next part of the question. Right. Then this integration. Here, Now we know how to integrate sine x and how to integrate cos x. Now the next objective is we should know how to integrate the rest of the what do you call that, trigonometric functions, right? Then if it comes to integration somewhere like this. 1 second. Yes. Then today, if you differentiate sec x, sorry, if you differentiate ln sec x, what is that answer? If you differentiate ln sec x, answer is 1 over sec x into differentiation of sec x. That is, if you differentiate any ln function, that is 1 over fx into f dash x, differentiation of that. So differentiation of sec x, we know that that is sec x tan x. Then it's turn up to how much? Just tan x. Then you can say, if you differentiate ln sec x, answer is tan x. Then I'll integrate the both sides. Then what happens? This differentiation and integration get cancels and turn up to integration of tan x is ln sec x. Right. Therefore, you can say integration of tan x is equals to how much? Ln sec x. Integration of same way to the tan ax plus b, answer become 1 over a ln sec x. That's the final answer for that. Right. That's the way of doing the integration of tan x. Right. Yes. The next one is today, if you differentiate ln sine x, ln sine x. What is the answer for ln sine x? That is 1 over sine x. Differentiation of sine x is how much today? Turn up to cos x. That means you can say differentiation of ln sine x is equals to cos x over sine x is today cot x. Cos x over sine x is cot x. Then if you integrate the both sides, then what can happen? These two get cancels. Then turn up to integrate of cot x is equals to ln sine x. Right. Then if you integrate cot x, answer is ln sine x. Right. So a plus b, x plus b also comes with the same format of equation. Okay. That's how it comes out. Then the next part is just like this. Then we know that what is the integration of sine x, cos x, sine x, tan x, and cot x. Then we should know what is the integration of sec x and integration of cosec x. These are the facts we should know today. Right. Then if you differentiate this much, if you differentiate sec x, if you differentiate ln cos x today, what would be the answer? Yeah. So make a 1 over cos x into cos x differentiation is minus sine x. That means differentiation of ln cos x is equals to minus tan x. Minus tan x. So that is another way of proving the ln sec x part of it. Yeah. Tan x of integration we already did. So this part is no need of doing because this one also comes with that. Okay. If you differentiate ln sec x tan x, if you differentiate ln sec x tan x, what would be the answer today? That is 1 over sec x tan x into differentiation of sec x tan x. Differentiation of sec x tan x, when you want to do, what you need to do is you have to consider this one as a product. Keep this and this one as u and v, right? Then keep sec x. And differentiation of tan x is sec squared x. Plus keep tan x and differentiation of sec x is sec x tan x. I write it here because other than that you may not see. Then you can see this part of it. Sec cube, sorry, this is into sec cube x plus tan squared x sec x. Right. Then what you can understand from this factor? Then you can say this is, you can take sec x out. Yeah, you can take sec x out from this differentiation. So this is turned out to sec squared x plus tan squared x divided by sec x tan x. Then you can cancel out these ones. Then you can say sec squared x plus tan squared x over tan x is equal to that. That means if you integrate the both sides today, then if you integrate ln sec x tan x, answer is equals to sec squared x plus tan squared x divided by, sorry, that is tan x today, integration of both sides. So in this case here, if you differentiate this, the integration and differentiation get cancels and turn up to this. These are little bit excessive formulas where we should know in the integration part of it. Apart from that, those are the very basic integration facts where we need to know. Apart from this, we should know how to do this integration of these facts today. What is the integration of sine x, integration of cos x, integration of tan x, and integration of cot x. Those are the main integration facts where we have to learn. Those things, integration of sec x and cos x, you can find it by this format. Because this answer is this. These ones are excessive formulas to do the differentiation, integration. This is make a proof this is ln sec x plus tan x, and this is minus ln cosec x plus cot x. These are the formulas for that today. Then you can do the same thing. You differentiate this, then you get this answer. Then if you differentiate this, definitely you will be getting this answer. With that, you can use the opposite operation and you can show this integration. So those are the first basic formulas where we should know under the integration of trigonometric functions.
Sir?